Yeah, I'm a software developer here in town. I work for a company called Tend.ai. We connect robots to the cloud. And I have an architecture slide at the very end of this that if by some miracle we have time, I might, I don't know, talk about if that's interesting. Yeah, so let's dive in here. Is there, where's the button I hit?
To record?
Well,
or just to so you can just use the arrow keys. I'm just trying to make sure this is actually going to stream real quick, and then it should be good. I don't know if someone can confirm any of it that it's online though.
So
the button to do the presentation.
But yeah, you can just use like the arrow keys on this thing, and it should be. If that's all right. That's all I have. So.
Okay.
Cool. Yeah, this should be working now. So. And
what's a Brufa?
Brufa is what happens when you, like in the early days of the internet, you like start signing up for websites with a throwaway name that happens to be an anagram of foobar. And one of those websites turns out to be useful for a while, and so you adopt it as sort of your moniker. And now it's like, it's just the default thing. Like nobody else has it, so I hang on to it. Cool. So let's see. So what are promises? According to the source of all truth, Mozilla Developer Network, a promise is an object that represents the eventual completion or failure of an asynchronous operation and its resulting value. So it's really all about capturing the state of asynchronous operations. So why are they important? Promises are important because we assume most of us are familiar with JavaScript, which is in broad terms, is a single-threaded environment that at its heart has an event loop. And the event loop consists of generating events from various input-output sources. In the browser, this tends to be user interface events like mouse and keyboard. In node land, it tends to be things like database or network activity streams, database requests, so on and so forth. And then processing those events to trigger callbacks in user code space. And you go around and around in a single thread. And the reason why promises are important is that if you get this wrong and your code tends to block, then it stops the world. And you see this in the browser with pages that hang and alert panels that ask if you'd like to kill the page. So, and Judge Judy doesn't wait for your code. So I couldn't resist. But JavaScript's been around for 24 years now, something like some grossly long amount of time. And yet promises are relatively new. So why are they important now? And that was actually an interesting question for me, since I've been doing a lot of JavaScript, and it's really just in the last year and a half where promises have really showed up on my radar as an everyday tool that I use. And as I was walking through this, like it became really apparent to me, like when you start looking at the JavaScript ecosystem and the direction it's been going over the last 5 to 10 years, we have better code packagers that allow us to make larger single-page apps. We have more web app frameworks, like the Vue and React and Ember and Angular, that are more sophisticated and that allow us to write more complex code. We have HTML5 APIs that are coming out like every 4 months or whatever it's been. All of these APIs tend to have asynchronous APIs. And then you have the exponential growth of the NPM ecosystem, which is the graph on the right here. So there's just a ton of code out there that didn't used to be there. And much of this is really sort of enabling more sophisticated async operations. And a lot of it is actually promise enabled. And then lastly, you have Node.js, which has opened up the whole server-side domain of problems, where asynchronous tasks are just fundamentally different and generally more sophisticated. We're not processing mouse events to do drop-downs anymore. We're doing like multitask, sophisticated database and network interactions that need to happen in an efficient manner. So all of which is to say complex async tasks are more the norm than the exception now. So I'm going to hand this over to Beej at this point.
Sweet.
Yeah, you're up, dude.
All right. So this is the first handoff. We're going to kind of all talk for a while, and then we'll do some live coding or something. I can't quite remember how this is going to go.
Yeah.
We'll get to one of the slides. So JavaScript is asynchronous. We've already mentioned this. There are different ways of handling the asynchronous calls and getting information back from those and dealing with that. Historically, there have been a couple ways of doing this using events and callbacks. And both those ways of doing things have served us pretty well, but have a few problems that we probably all run into over the course of development, and we'll talk about those a little bit. So how can we avoid some of these problems? Promises came along and really helped out. Clarified code, made it easier to reason about asynchronous stuff. And as if that wasn't enough, then we got the async and await keywords, which add some syntactic sugar to all this that make it even better. So let's tear into some of this stuff.
I can jump on this. So
this is yours, yeah.
Yeah, I threw this slide in here. So like, once you start writing async code, you realize there's a lot of sort of challenges with it. Control flow in general is hard. You've got serial and parallel operations that need to be managed. You have conditional code paths. Like if you have one path, you need to do an async operation, and another path you don't. That actually turns out to be non-trivial. You have code structure. Like how do you structure your code around doing multiple async interactions? And then lastly, like error handling is just nasty, or at least it has historically been nasty. The good news is it's gotten a lot better. And I'll just sort of skip over the debugging side of things, because that's
all right.
Too. Like all of this stuff gets better with promises.
We're going to also have these slides available somewhere, I'm sure, so for reference. All right, let's see. This is just a little hint in case you're not that familiar with this particular syntax, because we use a lot of it in the demo here. You might be used to having anonymous functions declared this way. You can declare an anonymous function using this shorthand notation in ES6. So we do a lot of that.
Actually, I have a question. How many people are familiar with ES6? Like, can we just give a show of hands? Okay, so pretty good audience. All right.
So to elaborate again, this is AB, that lower line there, is declaring an anonymous function that takes two parameters, A and B, and then has the function body afterwards.
I'm going to be doing some ES6 magic in the live code, so if you guys have questions, definitely speak up.
All right, I wanted to talk about a couple things that could go wrong. This is kind of a rarer one. We discussed last night if we were going to include this slide or not, but yes, we will, because it's actually something that promises do for us. If you have some asynchronous process and you're listening on an event for that process to finish, and that process finishes before you add the event listener, then you're out of luck. You won't get an event for that process finishing, and you won't realize that it's finished. This is one of the problems with event handlers. It doesn't actually occur that often, but promises.
It's impossible to debug.
Yes, it doesn't. I actually was pushing Beej to like, maybe we should get rid of this slide, thinking because I'd rarely run into this in the browser, but where you run into this is on the server when you have like unrelated sets of code that both depend on something that needs to be initialized. And so they both call like a init on it, and one of them wins, and the other one is like, wait, I'm still waiting for this to initialize because it never got that init event. So that actually happens quite a bit, that pattern. So,
and promises will cure that.
And promises actually solve that really pretty elegantly.
Right. Let's see here. So another common approach here is to have a callback. This is probably the most common thing you guys have seen. Do some asynchronous thing, have a callback occur. Node.js does this a lot. Does that actually solve our problem? Because there's no race condition here. Well, let's see. What if we want to do something a little more complicated? What if we want to run two asynchronous tasks in sequence? Then you start seeing patterns like this, where you have one long process that has a callback attached to it, and then when that callback is hit, then another long process goes, and that has a callback attached to it, and then when that callback is hit, then they're complete. Yeah. Now my code is starting to make me feel kind of dirty. So then stuff like this happens, of course. And you really start wondering if there's a better way to get your work done than this. Or if you're looking at somebody else's code, you're going, the Pyramid of Doom. Actually, I had not heard of this until you mentioned it. I'd always heard it called callback hell.
Yeah.
Which, but the Pyramid of Doom I like. So what if we want to do something more complicated? We want to run 5 processes at once, and then 2 sequentially, and then 3 more at the same time. Anybody want to write that? There is an example here on the next slide of something that we might want to do. This is a pretty realistic thing. That we
this is actually, I just sort of distilled down what we do to seed our database at 10 for on our test bed. This is the code, like get a test account, which may or may not exist. Conditionally, and all of these operations are async. So we're calling into RDB or MySQL. If no test count exists, you've got to create a new test account. Wait until that's finished. Create some test users. Multiple test users, which you want to do concurrently, just for efficiency. Then wait until all those have been completed. And then down below, you create some vendors, again, multiple app tasks concurrently, and you can create some sidekicks also concurrently with the vendor creation. So you can do a lot of stuff simultaneously, which is great for performance. But then we have to wait for those 2 steps to finish until we create our robots at the end, because our robots have associations to pretty much everything we've created up above. And then lastly, you want to block until it's done and then return. And so. There are libraries that help with this. We talked about there's a link to the async library ahead, or on the previous slide rather. But it very quickly gets really gnarly. And even with promises, this sort of stuff is non-trivial, which is why the async await code has been, moving to async await has been amazing. But async await is, as Beej said, is syntactic sugar around promises. So you really need to know about promises anyways.
And when I look at this code here, and try to think of writing it without promises, I just want to shoot myself.
Yeah.
It seems like so much logic would have to go in there, and maintaining that code would be so painful. And certainly the next engineer on it would shoot themselves. All right. What can we do to make things better? So this is a promise, or rather the use of a promise. So we have some process, load data, that takes a while. It's an asynchronous process. We have a couple other processes that take a while. They're also asynchronous, process data and store data. And by using promises, we're able to set up code that looks exactly like this, where we say load data. When it's done, then we process the data. And when it's done, then we store the data. And when it's done, there's another function there at the end. This is, again, one of those anonymous functions we were talking about that prints out that the process is complete. So this really helps to simplify the code. There's no callbacks here. We don't have the pyramid of doom. We don't have any problems with processes completing before we are testing to see if they're complete. And plus, it doesn't look bad, and it's easy to read. So let's talk about this a little bit more. Whoops, sorry, I'm about to skip 2. So the promise object, we'd already talked about this a little bit at the very beginning, but the promise object is the object that represents the future or current state, maybe I should call this current state, of the asynchronous process in question. And so when you use a promise, you're getting this object that says if the promise is pending, that is, it's not complete, if it's resolved, if it is completed successfully, or if it is rejected, if there's been some kind of failure. And the cool thing is, if for some reason the asynchronous process has already finished and resolved, when you check the process there, it will tell you that it has been resolved. So we're avoiding that problem where we have the race condition that Robert mentioned, where two things start an async process, one of them wins, and the other is left there hanging, waiting for a completion event that never comes. They both get this promise that gets resolved in this way.
Yeah, actually, I want to sort of rephrase what you said slightly. You're not really querying a promise for its state. You almost never ask, like, are you pending, are you resolved, are you rejected? Because generally you're writing code that doesn't care. So when you have a promise and you say .then, you don't really care if it's resolved or not, because your callback will get called. So just to clarify.
Right. But I think,
and I'm not even sure you can actually query the state of
yeah, I'm not sure that you can either,
because standard promise.
Yeah, I think the state itself might be hidden away, and it's like you're saying that the act of interacting with it is what allows you to get the actual state out of it. And so in this example, we've got the read network request, which returns a promise. And the promise has a then method on it. And to the then method, you can pass another function. So the first function executes read network request. Again, that gives a promise back, which is why we can call .then on it. And then the then takes an argument, which is another function to execute. So we're going to execute all of these things. What do I call a lie here? Oh yes, that thing.
Yeah.
So the unfortunate fact of the matter is that then is kind of a complicated function, and depending on what you pass into it and what the function that you pass into it returns, it can behave differently. So that's what my little lie is about down there.
Yeah,
but
I think the takeaway here is that the functions that you pass to then don't necessarily have to return a promise. Then will always return a promise.
Yes. So we have a chain of promises here, basically, with one thing to do after another thing. And I think I talked about this on a subsequent slide, but all this executes at once. This is kind of an important concept to think about from a JavaScript standpoint. This entire line right here runs and completes pretty much instantly. All the sub-processes within it, these sub-functions, they take their sweet time. They're all asynchronous. But this line runs at once, and then JavaScript continues on with the execution of your program. All these functions will get called in due time. Like clearly database.lookup is not going to get called until load file JSON completes. But this one single line here that starts with read network request ends with that semicolon. That comes back immediately, and your JavaScript continues to execute while the other stuff runs in the background asynchronously. All right, so the result of the promise is passed into the then handler. You've noticed that we've been passing a function to then. So here's an example of a then function, a then handler function. So if we say load data and that promise completes successfully, the then method is going to get called, or this function that we passed to then is going to get called with the result of that action. So this is how we get our data back from some sort of long-running process.
Okay, so
it's time for some code.
Yeah, so actually I think that probably worked out well. So a good break point. What's that?
You just press escape and it should go around.
Sweet. And I'm going to have to look in one direction and type in another. This will be fun. Okay, so I'm just going to I'm going to do a very light bit of code to cover what we've talked about so far, and do a little ES6 stuff, and then we'll get back to the presentation. As I've said, stop if you have questions. I'm going to make this a little.
They're part of ES6.
That's a good. Well,
There's separate spec.
I'm sorry.
It's a separate spec.
Yeah, there's separate
You don't have
specs.
to load a library in ES6.
No, they're a built-in object in the browser. Basically, all modern JavaScript environments is sort of the short way of putting it. I think they got into Node in Node 6 or Node 7. It's Node 7. Yeah. So there are polyfill frameworks. Bluebird is the most popular and most powerful. Q I think has been around a little longer. I'll talk to more. We've got a slide on that toward the end. Okay, so what I want to do is actually just create a couple of async functions and then do some just run a few async tasks. And I'm going to keep this hopefully pretty light. So can we see? Let me make this a little bigger.
You win if I understand.
What's that?
You win if I understand.
Okay. So the first thing I want to do is create sort of the minimal, the hello world of async functions, which is to implement the long sought for delay function in JavaScript. If you want to just pause your process for a second without locking up the CPU. Like JavaScript hasn't had a way of doing that. You can do set timeout, which it takes a callback and calls your function, and it's an async operation. But I want a promise-ified version of that. So I'm going to type without caps lock. This is going to be a lot harder than I thought. Wow, okay. I'm just going to look down. And there's a nice delay in the video here. Okay, so I'm going to take a single argument of milliseconds. And I'm going to return a new promise. And we'll cover promise constructors, like how you build promises. And I'll talk to it briefly, so I'll try not to steal too much of Beej's thunder here.
No, that's okay. But the short part is that you can kind of look at promises from two perspectives. One is the user perspective, which is what we'll mostly be doing in the field, using other people's promise libraries. And then there's from the promise creator perspective. If you have something that needs to have a promise, it needs to be promise-ified, but it isn't. For instance, like XHR requests, by default in browsers, that's not a promise. That's just a thing that you do with some callbacks. But what if you want it to be a promise? Then you have to code up a little bit of code there to turn it into a promise, basically. And so that's what we're doing right here. Set timeout, normally not a promise, right? Set timeout takes a callback. But here we've promise-ified it. So we now have a function called delay that is promise enabled, if you can call it that.
Yeah. So very briefly, the new promise takes an executor function, which takes two arguments: resolve and reject. And I'm not going to have an error case here, so I'm going to ignore the reject arg, and I'm just going to have a timeout that calls resolve. So this promise will resolve after however many milliseconds. And
resolve means success.
Yes. And what I'm actually going to do, just for clarity purposes, is CodePen will run this every time I make a change. So I'm going to just clear the console. Whoa. Okay, come back. Yeah, is there a way around this? There we go. Nice. All right. So console is cleared. Never mind the giant. Okay. And so I'm going to do delay. Actually, I'm going to do a console.log start, and then I'm going to delay, and I'm going to delay 3 seconds. And then my coding style is I put my then statements on separate lines, and then I want to do just console.log done. All right, so start. If you're looking at the console down below, and done. So we have our first promise. Let's see here. Let me go ahead and do another. I have one more thing I want to do. I'm more laying groundwork for some more code demo. We'll get back to the presentation in a sec. So delay is sort of the hello world, but it only captures the creation of of an async task that waits. It doesn't really capture resolving to a value or handling errors. So I want to do one more function here, which is really the hello world of tasks, and I'm going to call it task. And I'm going to take a delay, and I'm going to take a val, like this. And I'm going to return delay. So the first thing I want to do is delay. And this is just repeating the delay function. But actually what I want to do is .then and if my value, actually here, I'm going to keep it simple for now. I'm just going to return val. How are we doing here? Okay. All right, so, and down here, instead of my delay, I'm going to say, I'm going to say task, and I'm going to say, hey, BendJS, and I'm not going to bother with shift. Okay, so we started, 3 seconds, we're done. What happened to my hey BendJS? Well, what I'm going to do is I'm going to change my then function here to be, I'm just going to take v, because I'm lazy. And I'm going to use nice ES6 token string format here, so backticks. And I'm going to log v. So I'm just going to log the final value when I say done. And it says done. Hey, BendJS. So I'm now capturing the value from my promise. And just for giggles, I'm going to throw one more task in here. Then v. I'm going to use same. I'm going to get dirty and use the same variable name. We'll just do task 1, comma, okay, more values. Let's see what happens. Start, 3 seconds, done, okay, more values. Oh, right. So why didn't we, I was actually expecting another delay in here. So dot.
There was, though, it was just 1 millisecond, right?
Well, it, what happened was I'm not actually logging in. I'm not actually logging on this okay more values line.
Okay.
So we waited 3 seconds, and then under the covers, oh, and it was 1 millisecond. So yeah, so let's do this. No, 1 second. All right. Console start, and actually 4 seconds are passing here if anybody's counting, because what's happening is we're doing the hey BendJS. That value is getting passed into my task, but I'm not doing anything with it. And then a second later, I'm passing okay more values. So that all make sense? Okay.
So by receiving the output of a previous promise, you're resolving it and passing it on to the next.
When the promise resolves, you receive the value.
Okay.
Is that?
Yeah.
So just to clarify that, dot then.
It's sort of like if you did a XHR request and you were waiting for the result of the request to come back over the network. When the result came back, then the promise would resolve. Okay. Then you'd receive the data from there.
Okay. So start. First task finished, 1,000, done, okay, more values. Is there anything more? I'm going to stop here, and we'll come back to this.
Right.
So
make it look even better.
I've got to figure out how to get back to the presentation. Present?
Present.
Yeah. All right. We don't actually suck too much.
What I love is that with computer guys, it's pretty much universal that we all suck at AV anything. I don't know why that has to be the case. I know I'm no exception. So in that previous code sample, we actually saw an example of then getting an onSuccess parameter passed into it. And that was the function that's going to be called when the promise resolves successfully. Actually, the promise only resolves successfully. That's being redundant. But so here in this case, though, we're actually passing in 2 arguments to then. We're passing one function that's going to be called when it resolves successfully, and one function to be called when it rejects with some kind of error. So here in our example, we've got these 2 functions. One says, yes, everything's worked, and the other says, oh noes, things have gone badly, and you're going to get to where the dunce cap at work. Let's see here. So we might also see this. This is, how should I describe this? I'm going to describe this as alternate syntax. And we'll show an even better way of dealing with this later. But one thing you can do is just put a catch call in there, and you pass a function to catch, and that function gets called if something goes wrong somewhere along this chain. So if process 1 fails and rejects, then your catch handler will get triggered. Yeah. And process 2 and 3 will not execute.
And for I've been doing promise coding on a daily basis for 1.5 years, and I've never done that first version where you pass 2 parameters to then. I always end up using .catch.
I definitely would think .catch is more common.
Yeah, there are subtle differences to the 2 forms, but we can get to that in a little bit.
If you wanted to handle a different error at each process, you would do that?
Yeah. So
because this one is universal for all three.
Right.
Yeah. So briefly, just as your control flows from one then function to another, errors will cascade through your promise chain until they get to a catch, which is so catch is has a little broader net for what it'll capture, whereas the on-error, I believe the on-error handler is that specific promise.
So
Yes, that's the case.
Process 2 has an error, then process 3 will not run? Or
That is correct.
Okay, gotcha.
Yes. So the error will short circuit it.
So this is more like your classic try-catch.
Yeah.
Yeah.
Yeah. And when we get into the async await stuff, we can start drawing analogies between try-catch and what we're doing here.
Can I emphasize the importance of adding a catch? By default, the spec will swallow errors. I answer support tickets, and this bites people all the time.
Really?
Linking can help you a lot to make sure that you add the catch. Also, I think the default implementation like now might actually throw an error, but I think for a long time was that if an error happened like process 2 or 3, and you didn't have a catch, it was just
went silent.
It would just silent. You would have no way of knowing what happened.
That is interesting.
I would kind of expect that unless you actually had a throw in there somewhere.
I believe
because the promise itself will exist in a rejected state, but that doesn't really mean anything special in terms of like catching an exception. I don't think. So if somewhere in process 2 it says, "Hey, we're gonna reject," then the next then occurs, but there's no on failure handler in there, so nothing happens. And then if we don't have a catch, I'm pretty sure the whole thing just vanishes.
So that won't catch
It has now like an unhandled promise rejection like callback. You can register globally, but you have to do it. And then I think in new versions of Node, like it will actually throw an error globally, but in older versions, like it was just like, oh, and look, your customers are complaining and you don't see anything.
Yeah.
Which is subpar.
Right. That's putting it lightly.
Will that catch promise rejections and exceptions?
As far as I know, the answer is no to that.
I'm sorry. What was the question?
So is it and?
But
so
actually,
is it
no. I take
promise
that back.
rejections and exceptions, or is it promise rejections or?
Because if we do a throw inside, it'll catch that.
So
but what if it's
the
like
answer is yes.
Okay.
So when you reject, you're effectively throwing an error.
Oh.
So
will it catch other non-thrown exceptions?
Yeah. So if your executor function, so if you create a new promise and you throw an exception inside the executor function, that is the code that you're using to sort of set up the promise. I believe it will result in a call to your catch handler. So we can test that.
We can test it. All right. What have we got? I've got 3 examples here, I think, just to kind of demonstrate how this works. So I've got the output from this sequence of functions here. So this is going to output 1 and then error 2. So promise.resolve, that's something you kind of see occasionally. It's actually a useful helper function from time to time. Promise.resolve will return a resolved promise. So this is me kind of cheating my way to start this promise chain for this example by saying, hey, here's a successful thing that just happened.
Yeah, and you would normally pass an argument to resolve, which is the value that you want it to resolve
right.
to. So it's useful if you have code and you're like, oh, I need to like I have a method that I want to guarantee will always return a promise, but I don't actually need to do anything asynchronous at the moment. I can just return promise resolve, and it's good to go.
So what we've got here is a resolved promise. So hooray, everything's good. Then we console.log1. So that gets printed out. And then the next thing we do is we call the nextBend function, which returns a rejected promise. And it has failed for 2, the insidious 2 reason, which causes that promise to fail. And then console.log3 does not happen because we have a rejected promise at that point, and then the catch does occur, and that thing prints out the error. Straightforward enough. So Another one of these, this one's kind of funky, and I don't really like it as a coding style because if you were reading the code, you might not see what is exactly occurring here. But what we have here is a similar thing. We print 1, we reject 2, 3 does not happen, console log 4 does not happen, but in the then there is a handler for a rejected promise there. The second argument, like Robert said, he never sees, he always does a catch. He never puts the second argument. Plus this is horrendous coding style that I've mixed having a second argument to then and having a catch, which is bound to cause trouble. But
so the for on air will actually get called because of the promise reject above it?
Yes.
So it's not scoped to that function?
I'm almost positive I actually ran these to make sure that I got it right.
So that might be worth running. Okay.
If the console log 4, which your last one, this is the one reason to use catch instead of the on-air callback, is that if, say you didn't have the console log 5 with a catch, if console log 4 threw an error, it would be swallowed.
Right, there would be nothing to handle that.
So the on-air will only handle the things above it. So ending things with a catch.
And is that on-error running because console log 3 didn't happen? Is that?
It's running because there was a rejected promise returned on the second stage. Yeah, on line 2.
So the underlying error handlers, like we said before, don't actually work to differentiate between the errors. It's going to get called down the line because it's defined into and still hits the error handler before, even though that's not what the error handler.
Right. And I can clarify a little bit. In this anonymous function on line 2, when you have an anonymous function like that with a single statement in the function body, it returns the value of that statement, that expression. So that on line 2, we are returning a rejected promise there. And that is what's getting looked at with subsequent lines. So on line 3, they're like, hey, have we got a resolved promise? No, we don't. So never mind, I'm not doing anything because I don't have a handler for a rejected promise in line 3. Line 4 is like, hey, do we have a resolved promise? No, we don't. Do we have a rejected one? Yes, we do. I'm going to deal with that and print out caught. And at that point, the chain is happy again and continues executing and prints out 5.
That's probably why everybody uses .catch instead of using inline error handling.
Yeah.
It seems like the logic of how it executes.
It's just like a little bit more readable code too, honestly.
For sure.
More explicit.
So could you reject where you're actually saying like the log caught, and then it would skip over 5, I would assume?
Actually, what? Yeah, I guess so. I guess you could return a rejected promise
like
from the rejected promise handler.
Like dirty state at that point, because the catch still happens at them.
Yeah, so I think if you returned a rejected promise from the rejected promise handler in line 4 after you printed out caught, then I think it would skip line 5 and then catch at the very end again.
So
two
quick comments on this one. One is this sort of like we have a very linear chain of promises here, but you can imagine like take one of these, like take like the console.log 3, and instead of console.log, we have another like promise chain within that method that we're creating where we return a promise, and that one like that has catch blocks in there. Like it stops being a chain and becomes a tree of promises. And I've been doing this for a year and a half, and I'm still not really sure how all this works. So that was my first comment. And the second comment was when I was learning about promises, I wrote a lot of little tiny test cases to figure out behavior, because it was just like I did a lot of head scratching. Promises are one of those things where you beat your head against it for a while, and then you kind of get over the cliff, and it's like, okay, it all sort of makes sense mostly, except for where it doesn't.
Can you do it then after a catch if you want?
Yep.
Yeah.
Going.
I mean, the catch effectively acts as the end of a try-catch block. And if you have more stuff below it, like, okay, great. Keep going.
When you are writing those toy programs, promise.resolve and promise.reject are really useful for helping figure this stuff out. Let's see what oh yeah, there's this question right here. Can you have a catch and then a then? Yep, you totally can. So the catch will catch whatever happened before it in terms of a rejection, and then processing will continue.
I was just going to put a more live code slide in here. Did we? Yeah.
All right.
Okay, so I'm just going to repeat what we've all just seen, but in code. So it'll be fascinating, I promise. Come on, come back. Oh, hey, there we go. All right. So I want to write some .catch blocks, but in order to do that, I need things that throw an exception. So what I'm going to do is I'm going to come back up here to our task function, and I'm going to make this really simple. If value is, or if my val is an instance of error, I'm going to call, what am I going to do? I'm going to throw val. So now I have a function that I have a task function that I can sort of direct to throw errors. So this is very much a demo function here. I can create promises, I can pass them functions that come back, or pass them values that come back, or I can pass it an error that I'd like it to throw for me. So I'm just going to pick a line in here at random and do .then, task 1000, comma, error. What? And see what happens. Start. First task finished? Yeah. Hey, there's my uncut error. So I've thrown an error. And Chrome is actually nice enough to report it as an uncaught error, and it tells me it's in a promise. Chrome, by the way, is just phenomenal when it comes to debugging async code. I was trying to reproduce some of this stuff in Firefox earlier today, and I was like, this is why we're in Chrome today, right now. So I'm going to go ahead and throw a catch block in here. .catch error console.log error. No, I'm just going to say BendJS issue. I like my where am I? My template notation here.
I still do that every time.
Yeah.
I put single quotes, and then I'm like, I can go back and change it to the back.
Yeah.
I don't know how to break that habit.
Okay. Hopefully that's working. Oh, I have a, what do I do? BendJS issue what? Let's see, I'm just trying to understand. Yeah, okay, error. So.
No, we don't have a.
The stack, we'll just log the stack in here. I'm not, I'm not sure we really want to get into this. One of the issues historically with debugging asynchronous tasks is you spin off a task and then you let go of control, and then context that you have for where you created it disappears. And then later on, like your callback gets called, and if your callback's a generic thing like clean up network request or something, I don't know, and you're using it all over the place, you have no clue like which of the 18 places you created the async task actually led to your callback handler getting called. It turns out Chrome is actually really good about this. They actually remember that state, which I don't know when that started happening, but it's pretty awesome. So I'm going to hand control back. So I think it's probably better if I just we do the live code, cover what we've done so far, and then
all right.
There's one or two more places in here, and we can wrap up with questions or doing tests and stuff at the end.
I've forgotten already. Let's see.
There we go. Over on the right.
Oh, that thing's so tiny.
I know. Right. There you go.
All right. So we're going to talk about some more fun stuff here. I don't remember how many more slides we have until async will wait, but that'll be the next good bit. Promise.all is a really useful function for running multiple things concurrently that are asynchronous promise tasks. So in this example, we've got a delay task that delays a certain number of seconds. And what I'm saying here is I want to run both of these at the same time, and then resolve this promise when they both have resolved. So if you've got like 5 tasks you want to run concurrently, you can wrap them all up in a promise.all call like this. So in this example, we delay 3 seconds and 5 seconds concurrently. So the 3 seconds wraps up and nothing happens. And then 5 seconds wraps up. At that point, both promises are resolved. So the promise.all promise resolves, and we print out that we just waited for 5 seconds. So super useful when you want to do a whole lot of things at once. I had an example here that kind of describes this, where we wanted to do a bunch of database inserts, which all were async calls returned from promise. There in our for loop. So I want to do 100 of those things. And so here's an example where I get 100 promises back in that for loop very quickly. I push them all into my array and then the promise list, and then I wait using promise.all for the entire promise list.
So what order, if they return data, what order do you get the callbacks in? The order you sent them or the order they finished?
So you get this in, well, when promise.all returns, you will get, actually, it returns the array. And then,
I'm sorry,
there's another slide, right?
Is it,
that
what
does
order
exactly
do the
this.
results come back in?
What you get back is an array
Right.
where the position corresponds, of the results corresponds to the position of your promises that you passed promise.all.
So if your for loop just returned I, would it print out 1 to 100, or would they be maybe out of order?
No, they would be in order.
Okay.
Yeah. The promises may resolve at different times, or take different amounts of time to resolve, but the order of your results always corresponds to the order of the promises that you gave promise all.
Right, so promise all, it returns a promise itself. And the results of that promise are this big array of the, when it resolves.
Yeah, I can do a little live code with that.
Did I hear another question over here, or no? Sorry?
Yeah.
I've never heard those terms before. In terms of, like, what's pipe versus compose?
Well, piped is sort of the order they go in is the order they come out.
Right.
This isn't really a stream thing so much though, so it's just arrays, and it just maintains positional order.
So it's probably more accurate to say that, it is just an array that comes back. So if we've got 100 promises, when the promise resolves, you just get a big array back, and it is in the order that my promise list array was. So the first one of those is the first one in the results.
If you go back briefly, I just want to briefly mention, we have covered the entirety of the promise API function surface area, with one exception. There's a promise.race method, which will resolve as soon as one of the promises you hand. It's just like promise.all, except instead of resolving when all of the promises have fulfilled, it resolves when the first one fulfills. Right. I have never used it. So,
but then if you console
I have not either.
Yeah. So, but it's good to be aware of.
Like
and promise.race, do you remember the result? Is it just the result of the winning promise?
I think so.
And then the rest of them, do they go into the ether, or?
I would assume so. They haven't resolved. So.
All right. Eventually they resolve. And
so.
They lost Beej.
They lost.
Dead.
Non-promise results. I wanted to point this out because it is important. A lot of the things that happen in then blocks aren't actually promises themselves. So, and we've already seen that where we have handlers in there that console log something but don't return anything. So here are some functions that return goats and 3490. If you return a plain value like this, then it's as if you would return a new promise that was resolved to that value. So the promise chain of then stays all happy, even though we don't have any promises kind of explicitly declared here. They are implicitly declared. So goats, even though that's not really a success or failure thing, it will behave as if it were a successful resolution of the promise.
Yeah,
and that'll continue on to the next line. And when we see console.log, in fact, prints the result, and it is equal to the value that was returned from the previous then.
Yeah, this idea that that .then, or that that when you return a value, it sort of manifests as a promise regardless of whether or not you return a promise, is important in the async await side of the world as well. So we'll come back to that.
Hey, it's time for code already?
Yeah, why not? Let's see, so returning non-promises from thens and promise all. Okay. Escape. So we'll make this quick. So I want to do a promise.all in here somewhere. I'm just gonna kind of stack some stuff on here as we go, just for giggles. Okay, so down here, I'm gonna do .then. And I'm going to return promise.all. I'm going to compose a promise. And I'm going to do, what am I going to do? I'm going to task. I'm going to just do 100 milliseconds because I don't really care about this being fast. I'm going to do A. So I'm just going to do ABC. B, C. Actually, let me do AA, BB, and CC. Okay, so do I have, it looks like I'm missing something here. What did I do? I think I'm good. Okay, so, right, so I have, I've added a new then. Oh, here's a problem. Just so my indentation's messing with me. And I guess it's just going to be what it is. So in this case, I am creating a promise. I hand it 3 tasks. And if they all take 100 milliseconds and resolve to different values. And I then, at the bottom here, I do done, and we can see I get an array. So actually, let's just do some dot. I'm going to just make a little more literal. There we go. And actually prove that what we have is an array here. First task finished. And then I've gotten my array with AA, BB, and CC. And even if I come up here and I make AA take a second instead of 100 milliseconds, I will get that same order of AA, BB, and CC.
It'll take a little longer to get there, but
yeah, it takes a little longer to get there. And then the other thing was literal values. So, boy, this is going to just get messy, but what the hell?
Another then.
Yeah, another then. And I'm just going to return 1, 2, 3. Start. First task. 1, 2, done. 1, 2, 3. So again, I've got my value my literal value I'm returning as opposed to a promise, and that gets passed to the next handler function. So, oh, here. Let's get this back.
Can you try to erase instead of an all?
Yeah, sure. What the hell?
Yeah.
I like that idea.
Wondering what would happen when we did this. So, I'm kind of especially curious since we tell it's neck and neck for B and C.
So we got B. All right. So let's just
maybe because B was first.
Yeah, it returns the first winner. I'm putting 1 millisecond in here. Let's see. Yeah, how about that? So 1 millisecond difference, and we get C. So does that make sense? You all good? Okay.
It so freaks me out though that the results of A and B are just like, yeah, we finished. It's almost, I could just imagine like standing out in the desert and looking up after doing all their work, and they're just like, hello, guys.
Well, so this is one of the interesting things about promises is that the promises spec does not allow you to cancel a promise.
Well, it's a promise that something is going to happen in the future, so I mean you can't cancel it.
Well, yeah, but like when you make a network request, you sometimes want to call abort. But it's interesting. There are cancelable features. Oh, is this really the next slide? Oh, okay. Speaking of the inability to cancel, hey, there's a cancel method. It is good to, so when you get into promises, and if you're not in an environment that supports async await, or necessarily has the promise API built in, There are a variety of modules. The one I would really recommend is Bluebird. It is far and away the most popular and most powerful, and it served me well for a better part of a year. It has the standard Promises API that we've seen so far. It's called Promises A+. But it also adds a bunch of flow control methods, so you can do maps and reduce and filters, and you can cancel promises. And it has a bunch of convenient methods for basically setting up promises and managing the values that get passed out of them, so or that you get returned from them, rather they resolve to. Sorry, brain fart. I just will make a comment. As soon as we got to an environment that had async await, I deleted all of the module. I deleted Bluebird from our code because you really don't need it. Promise all and the built-in promise functions actually do most of what you need. So
what browsers
support async await?
Pop over to can I use and have a look.
Yeah, I'm just going to answer that one for us.
I was going to say Promisify is pretty magical and awesome because you can just toss anything to it, and I think as long as it ends in a callback, it will magically Promisify it.
Mm-hmm.
Here we go. Async functions.
And originally too, they were boasting that Bluebird was faster than the native promises, but I'm not sure where they stand now.
I don't care because because the native promises have such good debugger support. Like you just get Bluebird out of the way, please. And I loved it. Like I loved it while I had it, and now I'm done with it. So async await is supported on most modern browsers.
And every modern browser that matters.
Yeah. Yes, and some that don't.
You can also transpile it down.
Yes.
So.
UC browser like crazy popular in Asia?
Probably. I have no knowledge whatsoever, but that sounds really likely somehow.
Oh yeah. All right. So we've taken a while to get here. Like this is actually my favorite part of the presentation, and it's shorter because it really is just syntactic shares. But like async await has just been magical.
Can I ask how much shorter it is?
What are you saying?
Oh yeah, we have an hour already.
Yeah, we're at 7:40 right now. We need a few minutes to wind down, clean up before we get on here. So I'm just wondering if you can squeeze it in.
We can do it in 10 minutes. Does that work?
Probably.
I'll need. Hey Beej, can we do 5 minutes and then I'll do like a little async await coding at the end?
Sure. All right. So there's this slide, then there's this one, and this one. So now that we've talked about all this stuff about then and catch and all this stuff, we're going to kind of say that there's an easier way than all that. Although all that stuff is really important because conceptually what we're about to do is exactly the same as what we've been doing this entire time. So it was important to learn about promises and rejections and resolution and all that stuff. But wouldn't it be nice if we didn't have to actually type all this and there was something that we could type instead that would be easier? And this is where async await comes in. This is going to do the exact same thing. I'm going to pop back here. What do we got here? We're delaying one time unit. Then we print that out, we delay 3 more, and then we print that out. So let's look at this code that is doing the exact same thing. So what we have here is a couple new keywords. Let's look at await first on delay 1 and delay 3. This is saying we want to effectively wait until this thing is finished before continuing on with the next statement here in our function. So we will, I'm reluctant to say it this way, but this is kind of how it works conceptually, that execution effectively stops for 1 second on that first await line. Then we print out that's 1, and then execution effectively stops on the delay 3 line for 3 time units, and then we print out that's 3 more. When I say effectively stops, it's because it doesn't actually stop there. Just like I was saying before, remember, even though we have then with all these functions that are asynchronous and they run in their own sweet time, but that one line with all the thens on it, that executes immediately, and we continue on. Async functions work the same way. We've got the async keyword at the front. This function will execute all at once, but the individual lines within the function will be jumped back to in their own sweet time as our asynchronous calls resolve. So this kind of gives us the best of both worlds in a way. We can look at this code and we can pretend that it's actually synchronous code. So as software developers, we can reason about it as if it were synchronous.
We can read it.
Then you can actually read it. It kind of makes sense. Delay 1, then print 1, delay 3, and then print, that's 3 more. Under the covers, though, this is all promises, just like the then blocks that we had before.
Yeah.
So the compiler is taking care of this for us and making our world awesome, basically.
Yeah, the wait is basically wait until, like, you apply it to a promise, and that promise can come from anywhere. It doesn't have to be an async function. It can be a promise that you were passed, whatever. And it will just effectively pause execution without halting the event loop until that promise resolves. It's wonderful.
So syntactic sugar around promises is what we have here.
Yep.
And in fact, the async function do everything itself actually returns a promise that it will complete its entire function body at some point in the future.
The async keyword serves 2 purposes. 1, it guarantees the function returns a promise, and 2, it allows you to use await inside the function.
Yes, that's an important point. There is no await without async. If you try to use await without async, there will be problems. It'll let you know. Let's see here. We discussed last night what the purpose of this slide was. Oh yeah, so when you have a lot of the .then code like this, you replace the then with awaits, basically.
Yep.
And
I'll convert what I've done so far to async code.
Let's see here. Remember that it returns a promise, but the return value of the function itself, this is what the promise resolves to. So when the promise ends up resolving, its resolution value here will be x plus y. The function itself immediately returns a promise, but when the promise resolves, it resolves to x plus y. Does that make sense?
So if x is 1, y is 2, it'll resolve to 3?
It'll resolve to 3, right. Eventually. Yeah. Whenever x and y from outer space come back. And so we saw how to resolve there by returning the thing. So how do we reject? You can do a throw, just like we did before. So here's my distributed division on EC2. In case the divide instruction is too slow, you can send it out over the network.
You end up in Bitcoin somehow.
But of course, we don't want to divide by 0. That would be bad. So that would cause a rejection.
One thing that we should note here is that promises were sort of invented before, like as the JavaScript community's solution to async coding, without having control over the language. And async await is sort of the language standard catching up. So so everything that's sort of contrived in the promise way of like having to do .catch and .throw, you now do with much more intuitive constructs like try and catch and throw, that we've all seen in ES6 JavaScript. So
here's an example of catching rejection in a promise. Looks pretty similar, right? We've got try with some await lines in there, and if one of those promises rejects, then we catch it in our catch block.
Hey. All right, so I'm just gonna.
We're not at 10 minutes yet. We're almost there.
Yeah. Okay, so I'm just gonna convert some of this code, and I'm gonna start by async awaiting the functions up here. So what's interesting is I could just drop async on this, and it would still work. Now, I will note briefly, I am constructing a new promise explicitly in here. The promise that I actually get back from delay now will be different. It's a promise that wraps my promise, which you never really know or care about. Like it's just slightly inefficient somewhere in the bowels of V8. But I'm not going to do that because I don't need to be redundant. What I am going to do is make my async task. I'm going to make that async, and I'm going to just do await delay msex, and all that goes away, I believe, if I can get my code indented properly. There we go. So now, my delay function doesn't really get much simpler because I have to create a promise anyways. But my task function, because I already have a promise, like I just don't even really need to think about it. It's got this new pattern with async await, and I can throw just like I did before. I didn't really have to reject here. And so having done that, I want to now async await all of this code, or at least some fraction of it, depending on how much time we have. But I can't do that because I'm at the top level here, and I can't use await unless I'm in an async function. So let's. So what I'm going to do is I'm going to create an async function, and I'm going to invoke it. Okay, so this is nothing more than providing myself an async context in which I can use the await keyword. It's a little weird, but it's also a bit of a special case because normally you're already inside a function. Like 99% of your code, you're in a function. It's it's only that 1% that's your main entry point that you really care about. And then I'm just going to be bold and copy paste this and start and hopefully rip through this quickly. So I'm going to do await. Actually, what I can do is await task. And I'm going to reuse variables here. So I'm going to let v equal the value of that function. This code's going to be broken for a little bit. I can get rid of so it's all coming back to me now. When I converted the code at tend, basically what I did was look for .then and replace it with await statements. So let's see, we're in. There we go. Await. Oh wait, was that a catch? No, that was then. I really hope this works. V. Let's see. I'm not doing anything with V there, so await. Oh, hey, I've got a try catch block, and that is capturing everything above it. So what I really want to do is let v, so I have my code, try, catch, error. Oh, thank you, CodePen, for doing weird. I will clean this up in a moment. Stop me if this doesn't make sense. I don't know. I'm just trying to rip through this quickly. Okay, so we've got to try catch, and white space is critical to what we're doing here. So then I want to await, and I'm going to get do a little ES6 show. So let VV equal this. Actually, you know what? I'm not going to get fancy here. We're running short on time. How am I doing? Stringify VV, and it'll be a small miracle if this works. What do I got going on here? Undetected. Oh yeah. Can't believe you guys didn't catch that. Hey, one error. How about that? First task finished. BendJS issue error. What? Done CC. What happened to my array? Oh.
We're racing now. We're not promise.all. We're promise.race.
Oh. Huh. Let's go back to this.
.all.
Little did you know. Okay. All right. Fingers crossed. Hey,
so
there we go.
Scroll up there just a little bit to give a view again of the.
Yeah, sorry, I ripped through that, but
our await.
It's Adam's fault. Okay, so just to recap and point at stuff, the delay method, because I'm constructing a promise, I don't need to mark it as, and because I'm not using a wait inside of it, I don't need to hang the async keyword off of it. The task method, because I want to await on the delay call, I have to use the async keyword, and then I just anywhere I want to wait for the result of a promise, I just call await, and that's really the whole takeaway of all that, was giving you a sense of what it looks like to convert a promise chain in sort of the traditional promise style to async await code. One thing it does is it tends to it really sort of it creates a much more linear flow. Like even with promises, you tend to sort of have a lot of methods that are responsible for creating promises off to the side. It gets rid of that. And one nice thing that this does is allow you to I'll just briefly point at this as an issue. I'm not sure if we let me find a promise chain here. Yeah, so one of the things that happens, and I'm going to point here, is if you have state that you're capturing here, but that's not part of your return value, like if you have one piece of state you need to modify, you end up like creating these global variables up here that are then referenced sort of in the vowels of these functions here. Like if you have any closure state, and it's just ugly. If you have functions and you have functions here that are referring to state way up here, it's kind of weird. And async await really gets rid of all these different function contexts that you have with a traditional .then promise chain. So it makes the code a lot more readable, and it's hard to convey that in this demo that where we're not really doing any of that stuff. So I'm going to stop here. How are we doing on time?
I think we're out.
7:55.
So I could just say the rest of the slides, we'll put them online, and there's more stuff in there about writing your own promises in there. So yeah, so the rest of it's making your own promises and how to do that.
High five.
So do you want to go ahead and do round draft?
Well done, sir.
Everyone you trust me to
Tech Systems is the winner.